Good morning, my dear students. So in this session, I am going to teach you how to use your calculators, how to use the functions of your scientific calculators. So for the session, we are going to use an emulator of the CASIO fx-991ES. Since I observed that this is the most common calculator, most preferred by students. Okay, let's start. Let's start with something simple. So we have here an expression y divided by 2 plus x, and we were given values of x and y, x being 1 and y being 2. So the answer that we should get is 2. So inputting that in the calculator, so y is 2 divided by 2 plus 1. So the answer will be 2. So that's simple enough. And let's go to the next one. So in this expression, we have p squared plus m being 1 and p being 5. So let's input 5 first, and then we can get an exponent here in this button, x. And then let's put squared. Let's use this arrow to get in line, plus 5, I don't know, 1. M is 1. So you will be getting 26. Okay. Third example, we have z multiplied to the sum of x plus y, x being 6, y being 8, and z being 6 as well. So putting that in our calculator, z is 6. You can use parentheses here, and x is also 6, plus y is 8. Close that, and click the equal. Your answer is 84. Okay. We have an expression p squared plus m, or multiplied to m rather, divided by 4. So we have p squared, p is 7. So we have a function here, x squared. So we can also use that, times 8, 8, no, times 4, sorry. Divided by, we should put this inside the parentheses since they are one term, ano po, combined. Divided by 4. 7 squared times 4, the product of that divided by 4 will be 49. Okay, so let's try using this on kinematics equation. Ano po? So we are looking at the second kinematics equation right here. So we have the displacement is equal to the initial velocity times time plus 1/2 acceleration times time squared. So we were given the values of the initial velocity, the time, the acceleration here below. So let's just input that. So we have a 10 parentheses times 16. That this means multiplication as well. Ano po? When you're putting values side by side and then inputting them, and then one of them being inside a parenthesis, that's also multiplication. So we have three terms here, the 1/2. For 1/2, you can put 0.5, or if you want to really follow it, 1/2. Just click the fraction button and then 1/2 times 2.5 for acceleration times 16. Don't forget to square the 16. That will be equal to 480. Okay. So even though in the calculator you are able to input them in one line, you still have to show your solution. Ano po? This is just a manner for you to double check your answer. What I mean is you still have to show what 10 times 16 is, which should be 160. What is 1/2 times 2.5 times 16 squared in your solution. Okay po. Okay, now we are looking at the third kinematic equation. the Vf squared is equal to initial velocity squared plus the quantity 2 times acceleration times the displacement. So here in the third line, let's start here on the third line. So we need to first put in the square root, parenthesis 5.5. Let's put 5.5 inside the parenthesis, just so we are sure that the calculator is understanding what we want it to do. So 2 times, don't forget the negative in the 2, times 0.5, the displacement. The answer should be, okay, when you see a fraction here, you can actually convert this into decimal form by clicking this, the SD, and you will get 5.30, 3150, and so on. Rounding that to the second decimal place, 5.32 meter per second. Just click here so you can convert the fraction into decimal and vice versa. Okay, going to the next slide. Okay, so here we are looking at something simple. We are using the speed formula. I want to show you how to use the solver. When we are using the solver, we don't have to deal with the arithmetic and the isolating of the unknown. So we can just put 60, click on alpha, so you can get the equal here. The alpha is in red color as well as the equal. That means to get that function, the equal function, you have to click the alpha, and then you have an x. You substitute d, or you represent d as x here. Click again the alpha since x is red here, divided by 4. The calculator can actually solve the x for you. What you need to do now is to click the solve here, which is above the calc. So you have to click the shift since it's yellow, and then click the solve. Click the equal. X is actually equal to 240 rather kilometer. Okay, so that's how you will use the solver. Let's have another example. Okay, here what you're looking for is using the first kinematic equation is the x, or the time. The time is your x, which is here on this right side of the equation. So you have a 50 alpha equal, to get the equal, and then 10 plus, so 2.5, you have to multiply that to x, alpha x, close the parenthesis, shift, and then solve. Click, this was the previous answer. This is not your answer yet. Click on the equal to generate your answer. X is equal to 16. Okay, x is equal to 16. Going to the next equation. Okay, here was a problem a while ago. The same problem from a while ago, but this time around, let's use the solver to get the x, or the final velocity. So we have the x on the left side, square the x, get the equal, alpha, and then the calc to show the equal sign, squared plus quantity 2 times negative 2 times 0.5. Shift, and then the calc to solve. Click the equal sign. The answer would be 5.31. Okay, I think we should round that to 5.32 meter per second. Okay, another one. Now still on the third kinematic equation. So you have a 0 squared, although pwedeng hindi mo na square yun, but anyways, 50 squared plus 2 alpha x, I need to get the x, let's close that, times 25, shift solve, equal is negative 50. Your acceleration is negative 50 meter per second squared. Okay, Now I would like to teach you how to save or store rather values so that afterwards, um, so that it's easier for you to do the calculations. Okay, in this problem, we are given with points A, B, C, and D. And so actually we have three segments, A to B, B to C, and C to D. The problem here is you want to solve for the displacement for each segment. So for segment AB, segment BC, and segment CD. And aside from that, getting the displacement for each segment, you will have to add those displacement to get the total displacement. Ano po? Okay, so we have mm, 2 seconds for segment A to B, 1 second for B to C, and 3 seconds if you will travel from segment or from point C to D. The velocities are given as well. So for A, B, and C, we have constant velocity of 20 meter per second. That means our acceleration is 0. And finally, it stopped. The object stopped at point D. Velocity is equal to 0. So we will be using kinematic equation number 4 to solve for the displacement for each segment. So we put some notations here, A to B, and then here B to C, so that you can know what displacement we are solving. So for the sake of illustration, pinakita natin the substitution for finding the displacement from points A to B. So get the fraction plus 20 plus 20 is equal to divided by 2 multiplied by 2 seconds is equal to 40. So what if I don't have a piece of paper in my hand? How will I remember this value? So I can actually store the value. I have here above RCL, I have an STO that is short for store. It's color yellow. So I have to click shift and then RCL to access that. You can see here that merong STO store above. When where can I store that? I can store that here on the variables here. We have several variables like A, B, C, D, E, F, and X. So let's say I would like to store that on A. Store is already um, active here. So answer, which is 40, I will store that to variable A. Click equal. Delete one. Let's delete let's remove the values in the screen. Just to check if you were able to store that successfully, click alpha A. It should be equal to 40. Okay. How about B? B, the initial for B is 20 and the final is also 20. So 20 plus 20 divided by 2 multiplied by 1 second. So the answer is 20. Let's store that. Shift RCL STO active now. Variable B. Let's store that in variable B. Let's click this. B is equivalent to 20. Let's just double check. Okay, B is 20. And for C, 20 initial is 20, final is 0. So 20 plus 0 divided by 2 times 3 seconds. So your answer is 30 for segment C to D. Store that to point to C or to variable C. Okay, now I would like to add them. Let's just double check. C is 30. So alpha A plus alpha B, alpha, so I can get the C. 20 plus 40 plus 20 plus 30 will be 90. Okay, so that is the store function for you. Okay, just one thing to check if you know how to solve for angles using the trigonometric functions. So we have three triangles here. For the first two cases, um, it is the hypotenuse that is unknown. Ano po? So we can use the tangent function to solve for theta. In the third example, it is the adjacent angle, adjacent side rather, that is unknown. So we can use the sine function since the opposite side and the hypotenuse side are given. So tangent theta 5 over 12. So 5 over 12. Again, click SD to get the decimal form. 0.42. That's the value of the tangent function. But that's not what we want. What we want is the angle itself. So to get that, we can get the inverse of the tangent and then get this function, the fraction rather, and then input 5 over 12. Click equal so that the angle is 22.62 degrees. Just repeating that for the second equation, or second triangle rather, 15 over 8, 61.93. So sine theta is equal to 24, which is the opposite over 25. We're going here on the third example now. So pwede ka ding mag-inverse ng sine, di ba? You also have the inverse of sine here, the inverse of cosine here. So to access the inverse of the sine, just click shift since it's color gold or yellow, and then click the sine button. So you will get the inverse of the sine, 24 over 25, 73.74. Okay, so that's it for this calculator technique session. Thank you, Ed. Good luck, everyone.